Welcome to tissues. So far in Chapter 3, you should have reviewed your text and the PowerPoints on cell structure, mitosis, and now we're going to move on to different types of tissues. And this is part one of two parts when it comes to the identifying the names of the different types of tissues in our bodies. Histology is the study of tissues. A histologist will look at, for example, a slide prep of something that's a growth on an individual and identify whether those are normal structures with normal function or abnormally structured tissue, as you might see in a malignancy. There are four different types of tissues. They're in our body: epithelial, connective, muscle, and nerve. Epithelial tissue covers all of our body surfaces. It lacks on the superficial or apical surface of the cells a blood supply. At the basement surface, and we'll show some pictures of that coming up, there is a blood supply to aid in the mitotic division of new cells and new daughter cells. As the cells are pushed forward, they no longer have that blood supply. As you probably know, when a skin cell falls off, it doesn't bleed. You slough skin cells all the time and your skin's not constantly bleeding. Now, if you get a laceration into the deeper aspect of that epithelial tissue, yes indeed, you will find the blood supply. Epithelium reproduces rapidly, and some of our epithelium, such as that which we find in the trachea, contains cilia for the movement of product out of the lung. There are different types of epithelial tissues, and they are described based on their shapes and their arrangements. The three shapes are squamous or squamous, cuboidal, and columnar. There are simple arrangements where they're single layer thick, such as in the simple squamous, or the simple cuboidal, or the simple columnar. Sometimes there are pseudostratified combinations where there's still a connection to the basement membrane and has an apical surface of each one of the cells, but they appear to be as if they are layered. They're really not. They're still simple, but they are combined in a way that appear to be stratified. Stratified epithelium or cells are that which are layered one upon the other. There are also some layerings where they're not layered a single layer thick by a single layer thick, but a little bit more relaxed in terms of their combinations, as well as stretched, as you can see. And in stratified, as I mentioned already, it's not a simple single layer, but layers thereof of the same type of tissue cell. So we have stratified squamous, transitional relaxed epithelium, and transitional stretch described in your text and in this pictorial. If you look at this micrograph, they also show, if you were to take a slide of the tissue, and try to identify the types of cells, you can see, on a crosscut and with a free edge. If you looked at that term that says free edge, that would be the apical surface of that particular group of epithelial cells. And then you also look at the basement membrane of that particular group of cells. In this micrograph, once again, you're looking at a basement membrane and cells that are very close to the basement called basal epithelial, and then more superficial squamous epithelial cells distal to the basement area. And as you look at these terms, and many of you will work with the elderly, I want you to think about the fact that you've heard, oh yeah, Mr. Jones, he had a basal cell carcinoma, which is a very common skin cancer that involves those basal cells that you can see there misreproducing, and they're reproducing erroneously. It's not as aggressive of a cancer like a melanoma, but nonetheless you might see them come back from a small outpatient surgical procedure where they will have lasered off that portion of the cells that are abnormally reproducing. So I just want you to start to think about these names of where the location of that particular type of very common skin change occurs in the elderly. Now, epithelial cells are extremely helpful in protection. Some of them aid in secretion, and different structures within them aid in secretion, such as our sweat, and we'll talk about that in skin. Absorption, which we'll talk about when we get to the digestive system, and the villi in the gut that help us absorb our nutrients. In excretion, and also obviously in your skin too, we have many sensory receptors, but not just in the skin, but also in some of the other internal structures of your body, and also aids in surface transport. That was epithelial. Now we're going to move into connective. And again, this is just kind of an overview. Your text gets a lot more detail, data points to reflect on, but these are some of the terms that I want you to be sure to be familiar with as we go through this PowerPoint. Connective tissue actually is found in all parts of the body, and it provides a binding of structures together. Also can provide support and framework. It fills spaces, and it's the area where we store fat. Many of the different systems have connective tissue as part of their structure, and you may not have thought of it as connective tissue, but these truly are, and one of them happens to be blood. Blood is a connective tissue. It is one that obviously connects one part of our body to the other in terms of transporting many nutrients and oxygen and the like. And we'll talk a lot more about blood in the systems of transportation. Looser or realer tissue is found in that's bound to skin, that brings the skin from that layer to the underlying tissues, which is including the muscle. We find lots of connective tissue, loose or realer tissue, and other types of connective tissues around organs in our abdomen. Like, for example, one of the other connective tissues we have is adipose. Many of us are familiar with adipose tissue. If you look at the center of that micrograph, I always think of adipose tissue microscopically as looking like marshmallows. Now, you can make your own arrangement in your own mind of what you think it looks like, but I think it looks like marshmallows, and of course that makes me think of plumpy and fat, and fat, we all know, can store energy. It also gives us some protective padding, and more so than anything, it provides heat insulation. I take care of those little micro preemies who are born without any subcutaneous fat, and they cannot maintain their body temperature for anything, which is why they are in those incubators or isolates. We have to provide them external heat above the regular room temperature because of the fact that they lack subcutaneous fat and something called brown fat, and therefore they cannot maintain their body temperature, nor do they have readily available energy stores. Also in that pictorial you see a realer connective tissue and then fibrous connective tissue. And we, just like in the epithelial tissue, we will identify other connective types based on their structure, their density, their additional, whether they, their nuclear arrangements and the like. So as we looked at that third slide, that was fibrous or dense connective tissue. You saw that it was kind of looking more dense, strong fibers. These are ones that we actually find in tendons and ligaments. It also is a type of connective tissue that is found around the kidney and holding up the liver. The liver is a big organ, and if we didn't have some strong fibrous tissue to hold it in place, it would literally probably fall down to our, down towards our right hip. So there are capsules that are formed around some organs like the kidney and liver that aid in maintaining their position and protection. Cartilage is another type of connective tissue. It lacks a direct blood supply, which is why it, as well as things like tendons and ligaments, don't have the greatest blood supply. They are very slow to heal. If you've ever sprained an ankle, it actually will take longer to heal than if you broke the ankle without the sprain. We find cartilage at the ends of bones, in our ears, in our larynx, in the intervertebral disc, in the spine, and also in our knees and our pelvis. Bone is our last of the connective tissues that we'll make mention of. Bone, as we discussed before, is the location of storage of inorganic salts, or containing mineral salts like calcium and phosphorus. It is a highly vascular connective tissue, unlike the fibrous or unlike the cartilage. If you break a bone, there actually can be bleeding if you break through the blood supply. It also has a very large nerve supply, which is why if you've ever fractured a bone, and I'm sure many of you have, you know that it hurt really, really badly because it is containing a large nerve supply. So that's the very cursory introduction of the terminology related to the different types of epithelial and connective tissue. Next we will be discussing muscle and nerve tissue.